December 13th, 1972, 4:22 a.m. and 14 seconds, Coordinated Universal Time. Commander Robert Garrett and lunar module pilot Daniel Cole aboard Apollo 17 were completing their 74th orbit of the Moon when the spacecraft's navigation camera captured something that should not exist. The camera, a Hasselblad 500 EL, equipped with a Zeiss 250mm lens, the same camera system that documented every Apollo mission, recorded a structure rising 387 meters from the floor of Tsiolkovsky crater on the lunar far side. The structure was perfectly vertical, perpendicular to the Moon's surface, despite the Moon's libration, the slight wobble in its rotation that reaches 6.68 degrees. At that angle, at that location, in permanent shadow where temperatures hold steady at minus 173 degrees Celsius, no known material maintains structural integrity without active thermal management. No known material remains rigid. And yet, there it stood. Garrett was 47 years old, 14 years with NASA, a veteran of 3 Gemini missions with a PhD in geology from MIT. He had spent 847 hours in lunar orbital simulation, had memorized every crater, every mare, every documented feature of the Moon's far side. Cole was 42, former Navy test pilot, 2,300 hours in experimental aircraft, selected for Apollo specifically for his precision under pressure. These were not men prone to error, not men who misidentified geological formations, not men who panicked. When Garrett keyed the communication system to Houston, his voice was calm, measured, exactly as trained. Houston, Apollo 17. We have visual on anomalous structure, Tsiolkovsky crater, coordinates 21 degrees south, 129 degrees east. Request confirmation you're receiving camera feed. The response from Mission Control came 2.6 seconds later, the standard light speed delay for Earth-Moon communication. Copy, Apollo 17. We're receiving. Stand by. But 8.3 seconds into Garrett's transmission, the audio cut. Not static. Not interference. Complete silence. According to NASA's official mission transcript, the communications loss occurred at exactly 4:22 a.m. and 22 seconds UTC. The next transmission from Apollo 17 came 24 minutes and 47 seconds later. In that silence, something happened. When Garrett's voice returned at 4:47 a.m. and 9 seconds UTC, the tone had changed. Flat, monotone, scripted. Houston, Apollo 17. We experienced temporary signal degradation. Resuming orbital operations. All systems nominal. Cole's voice followed, identical in cadence. Confirm Houston. Nominal parameters. Continuing mission timeline. Controllers in Houston noted the shift. Flight director noted it in his console log. A handwritten note later archived. Crew affect markedly different post-comms loss. Recommend psych eval on return. But that evaluation never happened. The film cartridge from the Hasselblad camera, the one that captured the structure, never made it to the standard NASA imaging analysis facility at Johnson Space Center. It was diverted. Stamped with a Department of Defense classification marking before the command module splashed down in the Pacific Ocean. The classification, National Security Space Activities, the same designation used for reconnaissance satellites, for nuclear early warning systems, for programs where revelation could alter geopolitical stability, for a crater on the Moon. 2 men saw something at 4:22 a.m. UTC on December 13, 1972. 2 men trained to observe, to document, to report without bias. The camera recorded it. Houston received it. And in 8.3 seconds, someone decided the world was not ready to know. That Department of Defense classification remained in place for 47 years. The film cartridge sat in a secure facility at Wright-Patterson Air Force Base in Ohio, cataloged under a reference number that connected to no publicly accessible mission documentation, visible only to personnel with clearances that extended beyond standard NASA oversight. It might have remained there indefinitely, buried in bureaucratic layers designed specifically to prevent discovery, except for one detail the classification officers had not anticipated in 1972: the Freedom of Information Act, and the patience of researchers who understood that government secrecy has a half-life, that eventually, through systematic requests and legal pressure, fragments surface. In 2019, Dr. Jenna Voss, a specialist in satellite image processing who had spent 11 years at the Jet Propulsion Laboratory analyzing Martian topography before moving to independent research, filed her 17th FOIA request regarding Apollo 17 lunar photography. She was not looking for anomalies. She was mapping crater formation patterns, comparing Apollo-era images with modern Lunar Reconnaissance Orbiter data to track micrometeorite impact rates over 5 decades. What she received were 14 frames from the classified film cartridge, heavily redacted, released under a judicial order after a 3-year legal battle that NASA fought with unusual intensity for what they claimed were routine orbital photographs. The 14 frames showed Tsiolkovsky Crater from an altitude of 62 miles, captured during orbit 74. 13 frames showed the expected geography: crater walls, central peaks, the dark basaltic floor that marked ancient lava flows from 3.2 billion years ago. The 14th frame showed the structure. Jenna's first assumption was digital artifact, corruption in the scanning process, a shadow alignment that created the illusion of verticality, the kind of pareidolia that makes humans see faces in clouds and geometric patterns in random noise. But she ran the image through spectral analysis software, the same algorithms JPL used to distinguish between natural rock formations and human-made debris on Mars, software that measured light absorption, thermal emission, surface texture at the pixel level. The structure absorbed 99.6% of visible spectrum light. It was darker than Vantablack, the darkest human-made material, engineered specifically to trap photons. But unlike Vantablack, unlike any material in NASA's database, the structure emitted a constant thermal signature of -87 degrees Celsius. That number stopped her. Tsiolkovsky Crater sits in permanent shadow, no direct sunlight, ambient temperature of -173 degrees Celsius. The structure was 86 degrees warmer than its environment, radiating heat with no visible power source, no solar panels, no nuclear decay signature, nothing that explained the energy gradient. It violated the second law of thermodynamics unless something was actively heating it from within. Jenna ran photogrammetry analysis next, converting the 2-dimensional image into a 3-dimensional model using the same software NASA employed to map lunar topography for Artemis landing site selection. The structure resolved into 8 faces, each angled at exactly 22.5 degrees from vertical, forming a perfect octagonal pyramid with geometric precision of 0.003 millimeters. That level of precision exceeded human manufacturing capability in 1972. It exceeded current manufacturing capability. The angles were not approximate. They were exact, measured against the Moon's gravitational field, against the curvature of the crater floor, against every reference point the software could calculate. And the position? Latitude 21 degrees south. Longitude 129 degrees east. The exact geometric center of the lunar far side. the point equidistant from every edge of the hemisphere that never faces Earth. Not near the center, not approximately centered. Mathematically, provably, precisely centered to within 15 meters across a surface area of 19 million square kilometers. Jenna calculated the probability of a natural formation occurring at that exact location with that exact geometry. The number was effectively 0. She published her findings in a peer-reviewed planetary science journal, carefully worded, presenting the data without speculation, letting the measurements speak. The paper received 47 downloads in the first week. Then an email arrived from an account with no identifying information, a Proton mail address that routed through servers in Switzerland, untraceable. The message contained one sentence: "You found the tower. Now ask why Apollo 17 Orbit 74 was never on the original flight plan." The sender identified himself only as Marcus, former NASA orbital mechanics engineer, retired, unwilling to provide credentials but willing to provide data. He attached telemetry files, trajectory calculations, fuel consumption logs from Apollo 17, documentation that should not exist outside NASA archives. Jenna verified the files against published mission reports. They matched perfectly, except for one detail: Orbit 74. According to the original Apollo 17 flight plan filed 6 months before launch, the spacecraft would complete 73 orbits before initiating trans-Earth injection, the burn that would bring them home. Orbit 74 was added 19 minutes before it occurred, commanded directly from Houston, with authorization from the flight director. The official justification: orbital parameter optimization for fuel efficiency. But Marcus had run the numbers. Orbit 74 consumed 3% more fuel than a direct 73 orbit return. It was less efficient. It made no sense unless the goal was not efficiency, but positioning, aligning the spacecraft's trajectory to pass directly over Tsiolkovsky crater at the exact moment when sun angle and orbital altitude would allow the Hasselblad camera to capture the structure in maximum contrast. Marcus's email ended with a question that connected 47 years to 91 million miles of silence. Apollo 17 was not the first to see it. Luna 3 photographed Tsiolkovsky in 1959. Ask yourself why the Soviets took 29 pictures of the far side, but only published 12. Somatoidur Sanantvanaidatur? Jenna spent 6 weeks tracking down declassified Soviet lunar photography from the Luna 3 mission, the first spacecraft to photograph the Moon's far side, the hemisphere that remains forever turned away from Earth due to tidal locking, invisible to human observation until October 7, 1959, when Luna 3's camera system captured 29 images during a 40-minute window as it swung around the lunar far side. The Soviet Academy of Sciences published 12 of those images in a triumphant press release that showed the world what no human had ever seen: a landscape of craters and Maria fundamentally different from the near side, darker, more heavily cratered, ancient in a way that spoke to bombardment from the early solar system, preserved without the volcanic resurfacing that had smoothed the near side into the seas and highlands visible from Earth. But 17 images remained unpublished, listed in archival logs as photographic anomalies due to processing errors, a technical explanation that satisfied Western analysts in 1959 who were more concerned with tracking Soviet missile capability than questioning missing lunar photographs. Jenna found the images in a Russian academic database, uploaded in 2017 as part of a historical digitization project, low-resolution scans with Cyrillic metadata that identified them as supplementary Luna 3 materials, technical quality insufficient for scientific analysis. 5 of the 17 images showed Tsiolkovsky crater. 4 showed the expected geological features. The 5th showed a vertical anomaly, described in the metadata as high-contrast artifact, likely chemical processing defect, positioned at coordinates that matched, within the resolution limits of 1959 technology, the exact location of the structure Garrett and Cole would photograph 13 years later. The image quality was poor, grainy, the contrast blown out from the primitive photographic chemistry Luna 3 employed, but Jenna enhanced it using modern algorithms designed for astronomical image reconstruction. The same techniques used to sharpen Hubble photographs degraded by atmospheric distortion. The structure resolved, faint but present, a vertical line that extended approximately 400 meters above the crater floor, consistent with Apollo 17 measurements, accounting for viewing angle differences. But more revealing than the image was the handwritten notation in the margin of the original mission report. A note written in Russian that Jenna had translated by a colleague at Moscow State University who specialized in Soviet space program history. The note was dated October 9, 1959, 2 days after Luna 3's flyby, signed by Sergei Korolev, the chief designer of the Soviet space program, the man who built the R-7 rocket that launched Sputnik and Yuri Gagarin, whose word carried absolute authority in Soviet aerospace decisions. The note read, "Requires verification, not artifact. Recommend targeted imaging mission Tsiolkovsky crater, high priority." That mission never happened. Luna 4, launched in April 1963, was supposed to orbit the Moon. It missed, flying past at 5,000 miles distance due to a guidance error NASA analysts considered suspiciously convenient given Soviet technical competence. Luna 5 through Luna 8, launched between 1965 and 1966, were all targeted at the near side, safe landing tests that avoided the far side entirely, despite the scientific value of imaging the unobserved hemisphere. Korolev died in January 1966 during routine surgery, complications from injuries sustained in Stalin's gulags decades earlier, and with him died institutional memory of what Luna 3 had seen, or so the official history suggested. Marcus's second email arrived 3 days after Jenna published her Luna 3 findings. This one contained a single PDF, a scan of a NASA internal planning document dated August 1972, 5 months before Apollo 17 launched, marked Confidential Flight Operations Planning Division. The document outlined a proposed Apollo 18 mission scheduled for July 1974, a timeline that fit within NASA's original plan to fly Apollo missions through Apollo 20 before budget cuts forced cancellation. But this was not the fictional Apollo 18 of conspiracy theories and found footage films. This was a real proposal, complete with crew assignments, landing site coordinates, and mission objectives. The primary objective, buried on page 7 of the 12-page document: surface reconnaissance and geological sampling, Tsiolkovsky Crater Secondary Impact Site, coordinates 21.03 degrees south, 128.97 degrees east. Those coordinates placed the landing zone 800 meters from the structure's base. The document specified camera equipment, seismic instrumentation, sample collection procedures, everything necessary for close-range analysis of something NASA officially claimed did not exist. The mission was canceled in January 1973, 4 months after Apollo 17 returned. Official reason: budget constraints, congressional funding reductions, shifting priorities toward Skylab, and the Space Shuttle program. But the cancellation memo, also included in Marcus's file, contained a handwritten annotation from the NASA administrator. Per agreement with Soviet counterparts under Joint Space Cooperation Framework, Tsiolkovsky region designated restricted zone. All future missions to avoid direct approach. TSET, the United States and Soviet Union, rivals in every public measure of space achievement, had agreed privately to leave Tsiolkovsky untouched. Jenna needed confirmation that the restriction remained active, that after 50 years, someone was still monitoring the structure, still enforcing the boundaries established in that secret agreement. She reached out to Diane Mercer, a data analyst she knew from JPL, who had moved to the Lunar Reconnaissance Orbiter Imaging Team, the NASA mission that had been mapping the Moon in high resolution since 2009, capable of resolving objects as small as 50 centimeters across, cameras powerful enough to photograph the Apollo landing sites and show the shadows of the flags planted by Armstrong and Aldrin, by Conrad and Bean, by Shepard and Mitchell, by Scott and Irwin, by Young and Duke, by Cernan and Schmidt. Diane had access to the complete LRO orbital catalog, every path the spacecraft had flown in 15 years of continuous operation, 847 complete orbits over the far side. Thousands of imaging passes that had created the most detailed map of the Moon in human history. Diane ran the search Jenna requested, filtering for any LRO pass that came within 10 kilometers of Tsiolkovsky Crater Center. The results showed a pattern that should not exist in a scientific mapping mission designed for complete coverage. 0 passes. Not a single LRO orbit had been programmed to image Tsiolkovsky's central region directly. The spacecraft had photographed the crater walls, the ejecta fields, the surrounding highlands, everything except the exact coordinates where the structure stood. In the high-resolution Lunar Atlas published by NASA and the Arizona State University, Tsiolkovsky appeared with a resolution gap, a blank zone where the most advanced lunar camera ever built had simply never looked. Diane sent one additional file, a note she had found in the LRO mission planning archives from 2008, before the spacecraft launched. Imaging priorities. Avoid direct nadir observations, Tsiolkovsky central coordinates per interagency guidance. Maintain minimum 10-kilometer offset all orbital passes. Interagency meant not just NASA. It meant Department of Defense. It meant agreements that crossed boundaries of scientific research into territories where classification and control superseded discovery. And it meant that somewhere in the bureaucratic machinery of space exploration, people were still protecting a secret from 1959, still maintaining the restrictions established when Korolev saw something that required verification, still enforcing the boundaries that kept Apollo 18 on the drawing board, and LRO cameras pointed anywhere except at the one location that mattered most. Marcus's final email came with an audio file and a name. Travis Chen, retired communications technician, 32 years with NASA, worked Apollo missions 10 through 17, specialist in telemetry signal processing, the person who decoded radio transmissions from spacecraft traveling 250,000 miles from Earth and turned electromagnetic noise into human voices. Travis had kept copies of everything, backup recordings made on reel-to-reel tape, archived in his garage in Florida, recordings that NASA never requested he return when he retired, because officially they had the master copies and backups were redundant. Except Travis's backups included something the official archives did not. The 24 minutes and 47 seconds of silence between Garrett's first transmission about the structure and his second, scripted transmission claiming signal degradation. It was not silence. It was encrypted. And Travis, with equipment he had preserved from 1972 and knowledge of encoding protocols NASA thought were forgotten, had spent 2 months decoding it. The audio file Travis sent to Jenna was 11 minutes and 32 seconds long, extracted from the center of the 24-minute silence. the portion where signal encryption was densest, where the waveform analysis showed patterns that matched NASA's classified communication protocols used for Department of Defense payload discussions, protocols designed to prevent Soviet interception during the Cold War, protocols that required both Houston and the spacecraft to have synchronized decryption keys, which meant the encryption was intentional, coordinated, not a malfunction, but a choice to hide conversation in plain sight. The recording opened with a voice Jenna recognized from mission transcripts, the Capcom on duty that day, call sign Houston, speaking with the controlled urgency of someone managing a situation that had no procedural precedent. Apollo 17, Houston. Confirm visual acquisition on target structure, coordinates transmitted previous. There was the 2.6-second light delay, then Garrett's voice, and for the first time in 50 years, someone outside NASA's classified channels heard what he actually said in that moment. Affirmative, Houston. Visual confirmed. Christ, it's massive. Cole, you getting telemetry readings on this thing? Cole responded immediately, his voice tight with the kind of precision pilots use when instruments show data that contradicts training. Negative on radar return, Houston. Structure is absorbing active ping, no reflection. Laser rangefinder shows 387 meters height, but infrared is lighting up. It's emitting heat. Then Garrett again, slower now, processing information that violated everything he knew about lunar geology. Houston, we're observing geometric patterns on the surface, octagonal symmetry, too precise for natural formation. This is not a rock. Repeat, this is not geological. The Capcom's response came faster than the light delay should have allowed, which meant he had anticipated the observation, had prepared the response before Garrett finished speaking. Copy, Apollo 17. Maintain current orbital distance. Do not deviate from trajectory. Imaging team is recording all camera feeds, continue visual observation, and report any changes. Dundos, for 8 seconds, there was only the background hiss of the S-band radio, the faint crackle of cosmic radiation passing through the communication beam, and then Garrett's voice returned with an edge that 13 years of test pilot discipline could not completely suppress. Houston, thermal signature just spiked. Temperature reading on infrared went from -87 Celsius to -82. Now -79. Houston, the structure is warming up. It's responding to us. 3.2 seconds of silence, longer than the standard light delay. A pause that meant Houston was conferring, deciding, calculating risks in real time. When the Capcom spoke again, his voice carried a different authority, the tone of orders coming from higher in the chain of command. Apollo 17. Abort imaging sequence. Execute orbital correction, Hotel 7 immediately. Authorization from Flight Director. Cole's response was instant, procedural. Houston, Hotel 7 puts us on fast return trajectory. We'll miss the planned. The Capcom cut him off, voice now clipped, final. Execute now, Apollo 17. Another silence, shorter this time, and then the sound of Garrett's breathing, controlled, professional, the respiration pattern of someone overriding every instinct that said, stay, observe, understand, choosing instead to trust the command structure that had brought them 250,000 miles from home. Executing Hotel 7. Burning in 3, 2, 1. Mark. The audio captured the service module engine igniting. A low rumble transmitted through the spacecraft structure, and then the transmission ended. What followed in the remaining 13 minutes of the encrypted silence was status confirmation, Trajectory verification. The technical language of spaceflight operations performed with mechanical precision. Two astronauts flying away from something that had reacted to their presence, something that had warmed itself as if waking, as if noticing for the first time in how many centuries or millennia that it was no longer alone in the vacuum. When the encryption ended and normal transmission resumed, Garrett's scripted message about signal degradation played for Houston and for history, the official story that would appear in mission transcripts, in NASA summaries, in every public accounting of Apollo 17. A temporary technical issue resolved, no anomalies, mission continuing nominally. Jenna listened to the decoded audio 17 times, cataloging every detail, every voice inflection, every pause. And then she did what scientists do when data contradicts expectations. She looked for corroboration, for independent confirmation that what she heard was real and not an elaborate fabrication. She found it in an unexpected place, an academic paper published in the Journal of Geophysical Research, Planets in March 2022, authored by a team that included researchers from NASA's Jet Propulsion Laboratory, the Lunar and Planetary Institute, and for the first time in any NASA-affiliated publication, scientists from Roscosmos, the Russian space agency. The paper's title was deliberately dry, bureaucratic in the way that significant revelations are often hidden in plain language. Unusual structural formation in Tsiolkovsky crater. Preliminary analysis of multispectral imaging data. Jenna had missed it when it first published, because it appeared in a geology journal, not in the UFO research forums or conspiracy websites, where she might have expected such a disclosure. Buried among papers about impact melt distribution and regolith composition, just another study of lunar features except for what it actually said. The abstract stated, in language carefully constructed to minimize alarm while maximizing technical accuracy, analysis of archival photographic data and recent orbital imagery reveals a geometric formation in the central region of Tsiolkovsky crater exhibiting structural properties inconsistent with known natural lunar geological processes. The formation demonstrates octagonal symmetry, vertical orientation, and thermal emission patterns that warrant further investigation. Preliminary classification. Architectural anomaly of unknown provenance. The word architectural appeared nowhere else in lunar geology literature. It meant designed, built, engineered, and unknown provenance was the academic equivalent of saying we have no idea who made this or when or why, but someone did. The paper included spectral analysis data from Lunar Reconnaissance Orbiter observations taken in 2018, 2020, and 2023, carefully targeted observations that contradicted Diane's finding that LRO never looked at Tsiolkovsky's center, which meant someone had finally pointed the cameras directly at the structure and published what they saw, hiding the revelation in technical language that only specialists would read. The paper's conclusion contained a sentence that connected 5 decades of silence to the present moment. Ongoing monitoring protocols have been established through international cooperation frameworks. Further investigation is recommended prior to planned human surface operations in lunar southern polar regions as part of Artemis program objectives. The southern polar region, where NASA planned to land Artemis 3, was 1,742 miles from Tsiolkovsky. Different hemisphere, different geology, different everything. But the recommendation suggested proximity mattered, suggested that whatever stood in Tsiolkovsky crater created a zone of caution that extended across the moon, suggested that before NASA sent humans back to the lunar surface for the first time in 50 years, they needed to understand what Garrett and Cole had seen, what had warmed itself when Apollo 17 passed overhead. what still waited in the permanent shadow of a crater on the far side, hidden from Earth, but no longer hidden from history. Diane's analysis of Lunar Reconnaissance Orbiter data revealed something the 2022 paper had not mentioned, a pattern visible only when comparing spectral readings across multiple years, a detail that required access to raw telemetry rather than processed images. The structure's thermal signature, that constant minus 87 degrees Celsius emission that had puzzled Jenna from the beginning, was not actually constant. It shifted, subtle variations of 2 to 3 degrees that occurred in specific years: 2018, 2020, 2023. Each shift lasted approximately 72 hours, a brief warming followed by return to baseline, and each occurrence was separated by almost exactly 2 years, a periodicity that matched nothing in lunar geology, nothing in solar cycles, nothing in any natural process anyone could identify. The next shift, if the pattern held, would occur in 2025. That date aligned with another timeline, one that had been public since 2017 when NASA announced the Artemis program. Artemis 3, the mission that would return humans to the lunar surface for the first time since Apollo 17, was scheduled for late 2025. The coincidence was too precise to ignore, which meant either the structure operated on a schedule that happened to match human mission planning, or someone planning Artemis knew about the pattern and had chosen the launch window deliberately, positioning astronauts to be on the moon when the structure next activated, when it warmed itself for reasons no one outside classified briefings understood. The question Jenna kept returning to, the one that framed everything she had discovered, was not whether the structure existed because the evidence made existence undeniable, but why governments had chosen this particular form of secrecy, acknowledging the anomaly in academic papers while simultaneously restricting direct observation, allowing researchers to publish data while ensuring no spacecraft approached close enough to resolve details that might transform architectural anomaly into something more specific, more definitive, more difficult to contain within the boundaries of scientific uncertainty. The answer, she realized, was not concealment, but management, a calibrated release of information that prepared humanity for a truth that could not be hidden forever, but also could not be revealed all at once without triggering the kind of civilizational disruption that topples governments and religions and every assumption we make about our place in the cosmos. Because if the structure was artificial, and if it had stood in Tsiolkovsky crater for the 3.2 billion years indicated by the surrounding lunar surface, then it predated complex life on Earth, predated oxygen in our atmosphere, predated everything except bacteria and archaea in ancient oceans, which meant whoever built it had been exploring the solar system when Earth was a planet of microbes, had been capable of interstellar travel or generational patience or technologies we cannot. Imagine while our world was lifeless rock and water and chemistry that had not yet stumbled into replication and evolution. And if they built something that endured for billions of years, if they engineered materials and systems that survived cosmic radiation and micrometeorite bombardment and the absolute cold of permanent shadow, then they were not just advanced. They were beyond our current comprehension of what advancement means. But the structure stands silent now, inactive except for those brief warming cycles, which raises the question that defines the Great Filter hypothesis. Where are the builders? If a civilization could construct something that outlasts continental drift and species extinction and everything we consider permanent, why are they not here? Why is the moon not covered in their cities? Why is the solar system not filled with their descendants? The Great Filter suggests that all technological civilizations reach a point where they either transcend to something we cannot detect or they destroy themselves, or they encounter something that ends them. And the silence of the cosmos, the absence of radio signals from a galaxy that should be crowded with life, if life is common, suggests the filter is real and it is effective. The structure in Tsiolkovsky might be evidence of the filter, a monument left by a civilization that passed through this solar system and then disappeared, leaving only a tower in the dark as proof they existed, a warning or a beacon or a tombstone that says we were here, we reached this far, we built things that would outlast us, and still we are gone. And if they are gone, if a civilization capable of building structures that endure for geological timescales could not survive whatever came next, then what chance do we have? We who have barely left our own planet. We who still fight wars over resources and borders and ideas. We who cannot agree on whether the evidence in front of us means we should approach or retreat. NASA has chosen, for now, to maintain distance. The Artemis landing sites, carefully selected after years of analysis that considered ice deposits and solar exposure and terrain navigability, cluster around the lunar South Pole, Shackleton Crater, and Nobile Rim, locations that offer less scientific diversity than Tsiolkovsky but provide something more valuable in the current calculus. Separation, 2,800 kilometers of lunar surface between human boots and whatever waits in that crater, enough distance to establish a presence without triggering a response, without warming the structure beyond those periodic cycles, without discovering whether the architectural anomaly is truly dormant or simply patient. Engineers have questioned the site selection, pointed out that Tsiolkovsky's central peaks offer mineral compositions found nowhere else on the Moon, that the crater's depth provides natural radiation shielding, that scientifically it represents a more valuable target than the polar regions. But those arguments have not changed the mission parameters, which suggests the decision is not scientific, but precautionary, driven by knowledge contained in briefings that remain classified, knowledge that started with Luna 3 and continued through Apollo 17 and accumulates now in data from Lunar Reconnaissance Orbiter and whatever other sensors watch that crater from orbit. Robert Garrett is 82 years old, living in a small community outside Sedona, Arizona, far from Houston and Cape Canaveral, and the machinery of space exploration that defined his life for 2 decades. Daniel Cole is 79, retired to the coast of North Carolina, a house overlooking the Atlantic, the same ocean where the command module splashed down 53 years ago. Both men stopped giving interviews about Apollo 17 in 2015, a mutual decision reached independently as far as public records show, both declining requests from documentarians and historians and journalists who wanted to mark anniversaries and capture oral history before the generation that walked on the Moon passed into memory. Garrett made one public statement after that, speaking at a private conference for Apollo veterans in 2017, a gathering closed to media where astronauts who had flown to the Moon could speak freely among themselves. Someone recorded his comment, leaked it years later in a forum dedicated to space history. "We went to the Moon to explore. We came back to protect." He did not elaborate. He did not need to. The people in that room understood that exploration and protection are not contradictory missions but sequential ones, that sometimes what you find is more important than what you sought, that knowledge carries responsibility, and that protecting Earth might mean keeping distance from things we do not yet understand. The 2022 paper used the term provenance to describe the structure's origin, a word that means source or derivation, carefully chosen for its neutrality, its lack of implication. The authors did not write creator or builder or engineer because those words assign intelligence, intentionality, purpose, and assigning those attributes to something on the Moon means acknowledging that intelligence exists or existed beyond Earth, that we are not alone and perhaps never were, that the universe has or had other inhabitants who came to our solar system and left evidence of their passage, and that acknowledgement changes everything. It changes religion and philosophy and our understanding of human specialness. It changes how we see our future and our past. It changes the meaning of exploration from discovery to contact, from reaching outward to meeting something that reached first. And NASA, for all its mandate to explore and reveal and expand human knowledge, also operates within political and social constraints that recognize some truths require preparation, require foundation, require a civilization mature enough to process the implications without fracturing. For 4.5 billion years, the Moon has orbited Earth in tidal lock, one hemisphere forever facing our planet, the other forever turned away. A division that protected early humans from seeing what might have been too much, that allowed us to develop astronomy and physics and rocketry while looking only at the familiar face, the one marked with seas and highlands we named after our own concepts, Mare Tranquillitatis and Mare Serenitatis, and all the other Maria that spoke to human dreams of peace and tranquility, rather than to the harsher reality of impact melts and ancient volcanism. The far side remained hidden until we built machines capable of circling the Moon, until we achieved the technology to see what had always been there but invisible. And when we finally looked, we found Tsiolkovsky and its central structure, proof that someone else had looked at the Moon before us, had chosen it for reasons we can only speculate, had built something meant to last, and then departed, or disappeared, or transcended, or died, leaving us to find their work and wonder what it means that we are not the first. In December 2024, NASA announced a new mission, Lunar Flashlight B, a small satellite scheduled for launch in late 2026, designed officially to map ice deposits in permanently shadowed craters, continuing work begun by its predecessor that failed to achieve lunar orbit in 2023. The mission parameters specify a polar orbit that will, over the course of 2 years, provide complete coverage of the lunar far side at resolutions high enough to identify surface features smaller than 1 meter across. The trajectory will pass directly over Tsiolkovsky crater 16 times per lunar month, cameras active, instruments recording. For the first time since Apollo 17, since December 13, 1972, since Garrett and Cole saw something warm itself in response to their presence, a spacecraft will look directly at the structure with modern sensors, will photograph it in wavelengths that reveal composition and temperature and geometric detail at scales that might finally answer whether architectural anomaly means remnant or ruin or something still functional, still waiting, still watching for the return of whoever built it or for the arrival of whoever comes next. NASA has stated the imagery will be released publicly, made available through the planetary data system within 6 months of acquisition, a commitment to transparency that represents either confidence that the structure will reveal itself as natural, however improbable that seems, or recognition that secrecy has reached its limit, that 54 years of classification and restriction and carefully worded papers have prepared us as much as preparation is possible. The question that remains, the one that keeps Jenna searching through data, and Marcus sending encrypted emails, and Diane pulling LRO telemetry, and Travis preserving his old recordings, is simpler than any technical analysis, more profound than any scientific measurement. Are we ready to know what stands in that crater? To see it clearly and completely, and without the protective ambiguity of limited resolution and restricted access? Are we ready to confront the possibility that the Moon, our Nearest neighbor, the object that has pulled our tides and lit our nights and inspired our poetry for all of human history, might have been chosen deliberately, positioned intentionally, made into a marker or a message or a monument by minds that thought on timescales we measure in geological epochs, and that we, looking up from our small blue world, are only now developing the capability to understand what they left for us to find?